Okay, so good morning. So in class, actually, we had started with English data structure, and we had talked about its representation as well as the different operations. I think we will go through briefly go through the topics once again for clarity. So we said a linked list is an ordered collection of finite homogeneous data. One second. Uh, It's an ordered collection of finite homogeneous data elements called nodes. Okay, and the nodes are the order is maintained through links or pointers. So these are the main concepts of a linked list. So we will look at a simple example of a linked list. Okay, so in this particular linked list, we are just storing uh, one number per node. Okay, we are not storing. In our example in class, we said in the linked list node, students information is being represented with admission number and name, etc. But in this we are only, say, let us say we are only representing, say, some numbers, say 8, 6 and 1. Okay, and so we have pointers from one node to the next, and also to indicate the beginning of the list, the pointer has to be there, right? Because otherwise, how do we access this particular node? So, and as convention, we said that the beginning, the node which points to the beginning is always given a name of head node. So, head node will point to the first node in the list, and to indicate that you have a last node, the last node will have a pointer which points to, or which has a value of null for that pointer. Okay, which means it is not pointing to any valid memory location. So this is how a linked list will look like logically. Okay. It has a set of nodes. Each of these is a node, and it is in an ordered representation, and the order is maintained using pointers. So this is a basic idea. Now, how do we actually declare, say, how do we represent it, say, in a C language? How do we represent each of these nodes? So that also we had come across earlier. So in this example, so we said every node will have a field for, or a part for storing the data, and a part for the pointers also. Pointers anyway it will be there. Okay. So in this, so it will be declared as a structure. Okay. So it is a struct, and name of list is given, and there is the data part is a character, but in a previous example it was a number, so we can call this int also. In our previous example it was integer, right? So this is int. So the data part is an integer, and then we have a pointer to a node. Okay, pointer to a structure like this, right? So the link or the pointer variable will have a type struct list star, right? So it's pointing to a structure. So that is why we have a struct list star here. So and what is given here is this list one is an object or a variable of type structure. So that object is created. Right. Now, in class, we had also talked about type def, using type def for declaring uh, a type for our node, right? So we say type def, followed by, again, it is of course a structure, right? So we give struct, easy to write on the struct, followed by a name. Let us say it is, we are giving a name of small and node E. Okay. So inside it we have to declare similarly whatever is required. Say int data, int data. That is our data part. Okay, and then you have a pointer. Pointer is of type. It is pointing to struct node, right? So you give struct uh, node star link or next, or any variable name you can give here. Let us say we'll call, since it is pointing to the next node, we'll call this next, right? And then you close this, and you can give a name for this particular data type. Now node becomes a data type. Capital node NODE is a data type. Now if you want to create say a variable of this type, you can say node followed by n1, right? So this is another way of declaring a node type. Okay, so these are different ways of declaring nodes. Okay, now okay, next we will move on to dynamic memory allocation, which again we had discussed in class. And here we had this declaration here, that is struct list followed by your the variable name. This happens, or this declaration happens at the beginning of the program before you use this particular structure. And as we said, this is called static memory allocation. Static memory allocation happens during compile time, right? When this program gets compiled, a certain amount of memory is allocated for this particular variable. But it is not always possible to have static memory allocation, because as we said, linked list, the number of nodes required for the list is not known to us. It is only known during runtime. So that is why we go for the dynamic memory allocation using malloc and so on, right? Okay, now how do we using malloc, how do we create the node? Okay, so malloc, so this is an example declaration or a function call. But in the case, suppose we are going to create of node type. Okay, create a node of node type using malloc. You have to give size of node, right? Size of node. This is our standard format. Okay, and as we said, it returns a pointer to type, again node star. So we are typecasting to node star. And so when we make this call, okay, when we make this call, malloc, what it does is it will allocate a structure of type this node we have created here, right? So it contains a data part which is of int and also a pointer. Okay, which means a space is allocated for storing integer as well as a pointer to, there is a pointer also, there is a pointer part also. Space for these two are being allocated, but accessing this memory, we don't know. Generally a variable has access to variable name. Since we're using malloc, this particular memory space does not have any variable names, right? So in order to access it, we need the address of this, the address of the first location of the structure. Okay, that is what is returned by malloc. Okay, and that we have to assign to a pointer type. Okay, pointer type. And the data type of this ptr will be again node star. Okay, so node star. Basically, when malloc is called, we know a structure is created corresponding to the structure we have declared here. And after that, in order to, a pointer is returned by this function. That is, it returns the address of the first memory location. The first memory location is 1000 anengil, then that 1000 will be returned. And when you say ptr is equal to 1000, okay, PTR is again a variable which is capable of storing a point. And when this malloc returns 1000 or the first address of this memory location or first address of the structure, so PTR becomes 1000. Okay, and which means we're saying it is pointing to the first memory location which is created by malloc. So that is what happens. Okay, now Now moving on to the different operations. So we said for any data structure, we will define the structure of the structure or the organization of the data that we have already looked at for linked list. We know it is an ordered list of nodes. Okay. And we also, so when a data structure is considered, we look at the data organization part as well as what are the valid operations on that particular data structure. So the valid operations are these: traversing the list. Traversing means going through every node in the list. Maybe you want to look at each of the nodes values. So you can traverse the list, insert a node into a list, deleting a node from a list, copy the list to make a duplicate list. You want to create another list so that the other may be used for some other operation. Merging lists with another to make a larger list, and searching. So these are the operations which we will be looking at. Okay. So right now we will start with inserting a node into the list.